Now in this lecture, we discuss about the gamma function and its related example. What is gamma function? So gamma function is defined as gamma of n is equal to integration under the limit 0 to infinity e to the power minus x into x to the power n minus 1 dx, where n is always greater than 0. Let us see some properties of gamma function. The first property is gamma of n equal to 1. Second property, gamma of n plus 1 is equal to n gamma n. Sometime if this n is positive integer, then gamma n plus 1 can be also written as factorial n, where n is any positive integer. Gamma of 0 is equal to infinity. Gamma m plus 1 by 2, which is equal to root pi upon 2 to the power 2m minus 1 into gamma 2m. Sixth property, gamma p into gamma 1 minus p is equal to pi upon sine p pi when p lies between 0 to 1. Eighth property, gamma of 1 by 2 is equal to root pi. These are very important properties of gamma function. When we solve some examples based on the gamma function, definitely use all these properties. Without using these properties, we are not able to find out the solution of the gamma function. Transformation of gamma function. Gamma function is, this is the original definition of gamma function, gamma of n equal to integration under the limit 0 to infinity to the power minus x, x to the power n minus 1 dx. Gamma n is equal to, this can be also replaced, another formula of gamma function, or we can say that transformation of gamma function. Gamma of n equal to 2 times of integration under the limit 0 to infinity e to the power minus x square x to the power 2n minus 1 dx. Third property is integration under the limit 0 to infinity e to the power minus kx x to the power n minus 1 with respect to x, which is equal to gamma of n divided by k to the power n. Fourth property, gamma of n plus 1, which is equal to integration under the limit 0 to infinity e to the power minus y whole to the power 1 by n with respect to y. And the fifth property is gamma of n equal to integration under the limit 0 to 1 of log 1 upon y whole to the power n minus 1 with respect to y. So these are some different forms of gamma function. Gamma function can be also expressed in this form. Let us take one example of gamma function, then it will be very clear how to use gamma function to calculate some integrals, which is very difficult to find out as usual method. Now we have to evaluate integration under the limit 0 to infinity gamma root of pi into e to the power minus y cube. We know that gamma function, gamma of n, is given by gamma n is equal to integration under the limit 0 to infinity e to the power minus x, x to the power n minus 1 dx. Now if we compare this given integration and the definition of gamma function, in place of e to the power x, here e to the power minus y cube, e to the power minus y cube. If we replace y cube by t, let us go ahead. We have to evaluate I is equal to integration under the limit 0 to infinity root of gamma root of y into e to the power minus y cube with respect to y. Putting y cube is equal to t, the y will become t to the power 1 by 3. And if we differentiate it, dy is equal to derivative of x to the power n is 1n and x to the power n minus 1. So 1 upon 3 t to the power 1 by 3 minus 1 dt, which is equal to 1 upon 3, 1 minus 3 upon 3 which gives us 1 upon 3 t to the power minus 2 by 3 dt. This is the value of dy. This is the value of y. And now, if we are changing the limit, if y tending to 0, if y is equal to 0, y equal to 0, then t will also 0. If y is equal to infinity, y is equal to infinity, then t is also infinity. If we substitute all these values in equation number 2, we have I is equal to integration under the limit 0 to infinity, root of y is equal to root of t to the power 1 by 3 and e to the power minus y cube will convert it to e to the power minus 2 minus t into the value of dy. The value of dy is nothing but 1 upon 3 t to the power minus 2 by 3 dt. Let us simplify this and we will try to convert it into gamma function. This 1 upon 3 we have taken outside. Next, t to the power 1 by 3 whole to the power, because it is a root sign, so it is whole to the power 1 by 2. E to the power minus t into t to the power minus 2 by 3 dt. T to the power 1 by 2 into 1 by 3 into 1 by 2, e to the power minus t and t to the power minus 2 by 3 dt. T to the power 1 by 6 is t to the power 1 by 6, t to the power 1 2 by minus 2 by 3 into e to the power minus t. T to the power 1 by 6 minus 2 by 3. Let us go ahead. T to the power 1 by 6 minus 2 by 3 into e to the power minus t dt. If we simplify it, t to the power 1 by 6 minus 2 by 3, 3 minus 1 by 3 into integration under the limit 0 to infinity, t to the power 1 minus 4 upon 6 into e to the power minus t dt, or 1 upon 3 integration under the limit 0 to infinity, t to the power minus 3 upon 6 into t to the power e to the power minus t dt. This is what? It is minus 1 by 2 e to the power minus t dt. It can be written as t to the power 1 by 2 minus 1, which is nothing but minus 1 by 2 into e to the power minus t dt. And this is nothing but 1 upon 3. Here, the value of n is equal to 1 by 2. If we compare both the formula, this is the definition or formula or expression for the gamma function. And if we compare these two integrals, only thing is that e to the power minus t, e to the power minus x, t to the power x minus 1, t to the power, no, this is not x, this is n, sorry, this is n minus 1. In place of n, we have 1 by 2. So this is equal to 1 upon 3 into gamma 1 by 2. And we know that gamma 1 by 2 is nothing but root pi. Therefore, it will become root pi upon 3. Hence, integration under the limit 0 to infinity root y e to the power minus pi cube dy is equal to root pi by 3. Thank you.